Morning, everybody. Well, at least it's morning when I'm recording this. About 6:20 in the morning. Had a little rough night last night, so I'm going to try to get through as much as I can today. Whatever I don't cover in this classroom, I'll try to cover in class today. So, let's begin. With this material here, we're going to move away from sequences and move instead onto something called functions, okay? Now, before we begin, you might want to record this vocabulary down. This is kind of the material that we're going to go through. I'm probably going to stop right around the intercept section, and the rest of this we can cover in class today. So, let's move on then. So, first of all, what is a function? Well, function is pretty much the most important thing we study when it comes to algebra and high school math in general. The biggest thing we want about an equation is that for every input we place into this equation, we have a unique output. So if I put in, let's say, 2 into this function, I know what I should get out. Whatever the rule is, there should only be one answer. Now, I might be able to have the same outputs, so if I put in 2 into my equation, I might be able to get 5, and I put in 5, I'll get 5, if I get 7, I get 5. That's okay. That's totally okay that we have the same output. What is an issue is if we have, we put in 1 and we get 6, and then we put in 1 later and we get 10. We don't want that. We want to be able to have, we should be able to predict what comes out. So I usually make the analogy about a Coke machine. As long as the Coke machine works and you can predict what you can get out, it's a function. So for example, if you put in $1 and you get 1 Coke, and you put in $2 and you get 2 Cokes, and so on, that's okay. That's a function. If you put in $1 and you get 5 Cokes, and you put in $2 and you get 5 Cokes, and you put in $3 and you get 5 Cokes, that's pretty predictable. Even though it's kind of a ripoff, you're still able to predict what happens. Now, if you put in $1 and you get 5 Cokes, but then you put in $1 later on and you get no Cokes, then that's going to be an issue. Okay, so technically speaking, a function has one output for every input, is what we like to say. And graphically speaking, what that means is if you have a coordinate grid here, and maybe this function looks like this. Okay, I should say the graph looks like this. This one's okay because it doesn't. If you have we use what we call the vertical line test in order to determine if a graph is a function or not. Meaning, if we put a vertical line anywhere on this graph, it should only hit the graph no more than 1 time. Now, it can hit it 0 times if we want to, but if I just pick an arbitrary x, let's say right here, okay, how many y values does it have? Well, it only should have 1 y value right here. Okay, whatever this is right here. Okay, hopefully that makes sense. Okay, let's see what's next. Okay, so I have a couple more functions here, things to test, and I have this fancy thing to help us with our vertical line test here. Okay, let's check to see if this thing is a function. Well, everywhere I seem to slide it only hits it once, so that's a function. Okay, let's look at this next one here. Okay, that one's good, that one's good, that one's good, this one's good. Okay, what about this guy right here? Oh, wait a minute, that one hits it twice. It hits it right here and right here. So this guy is not a function. That one's no good. Okay, the rest of these are good because when I took a vertical line and held it anywhere in the graph, it was working. Let's go ahead and move this guy back. Next page. All right, a couple of things we want to talk about when we're talking about functions. One would be domain and range. Another one is a place where they are increasing or decreasing. Okay, but in order to do that, in order to talk about those things, we need to first, I first need to show you how we write certain things. Okay, so these are the various notations we use for locations on a graph. Notice that we use parentheses when we don't want to include that number, and we use a bracket when we want to include that number. So for example, let's kind of use these here. Let's say I wanted to do, and I'll use the other notation for a second. Let's say we wanted to look at all the numbers between, let's say, -4, and that's the less than sign. Okay, let's look at all the numbers between -4 and 2. Okay, so in grade school you may have learned about this graphing portion here where you have an open circle, and I'm going to do the best I can with a mouse, no promises here. -4, and then we do the same thing here. Okay, and then everything in between is good to go. Okay. Now to write this using interval notation, we have a open parentheses, -4 is the lower one, and 2 is the higher one. Now we don't want to include both of those. Okay, if there was an equal sign here, an equal sign portion here, then we would be fine. Okay, we would want to include those. Okay, in fact, that's what the next one is saying, is if we wanted to include this one right here, then we would write it as -4 inclusive. Okay, so this one we do not want to keep. Okay, and in order to do this one, we just fill in the blue right here. Okay, if we want to include the right one, maybe we want to include 2 for whatever reason. Okay, then we would write it this way instead. Okay. All right. And again, this is one where we fill it in. And if we wanted to include both of them, if we wanted to have both the blue and the pink, okay, then let's see if I can do this right. Okay. You would want to do -4 all the way to, and let's say pink, 2 inclusive. Okay, so that tells you kind of, that's how you write certain things in math. So again, if you're talking about locations, if you're talking about sets of numbers, then you're going to want to use this notation, because while in sequences it was fine to just write out all of the numbers, this notation right here gives us all of the numbers. Now, if you have a sequence of numbers, you're going to be missing some. So if I said, okay, build a sequence between -4 and 2, you're going to miss some. You're going to miss some irrational numbers in between. But if I said, okay, give me all of them, then you're going to be wanting to write it like this. Okay, so speaking of domain, the domain of a function is the collection of all possible inputs. Okay, so it's what you're allowed to plug into a function. So just very quickly, if I have a function like x squared, I'm asking myself for the domain, what am I allowed to plug in? That's the big question with this. Let me write this in here right now. What am I allowed to plug in? And that's really what the domain is saying. It's what am I allowed to plug in? Okay, so with something like x squared, you can plug in anything you want. Okay, you can square 5, you can square -3, you can square 0, you're good to go. Now, a different function, maybe this one right here, the square rooting function, you aren't allowed to plug anything in. Okay, you're allowed to plug in 16, you can even plug in 10, but if you go into your calculator and you type in the square root of -6, it's going to come up with domain error, because you can't take the square root of a negative number in real number systems. Okay. So what does it mean graphically? Well, graphically, this is just all the x's that have y values. Okay, so if I'm looking at this right here, this x right here has a y value, this one has a y value, and really all of these numbers right here have y values. Okay, so my domain is precisely these values right here. Okay, now I just showed you how we could write something like this, so let's practice now. Let's see, the x values start at 2, and they end at 1, 2, or let's say 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Okay, so from 2 to 13, my function exists. Okay, so my domain, then including 2, all the way to 13 inclusive. All right, good to go on that one. All right, so that's the domain. Let's look at a different function. Let's see again. What x values have y values? Well, this -2 right here has a y value. This point right here, maybe that's right around a half. That one has a y value. Even 5 has a y value over here. Okay, and we see that this arrow extends, meaning it goes on that way forever. Okay, so let's look at that. So we want to include -2. Right here, -2 is the lowest value that has a y value. Notice these guys don't. Okay, so -2 is good, but where do we end? Well, this is where we would have a special notation here. This goes on forever. In math, we call that infinity. Okay, so we write the infinity symbol, which is very hard to do with a mouse, but okay. The infinity symbol, and then what do we include here? Do we include a bracket or just a soft parentheses? Well, infinity is not a number. You might have been taught that infinity is the largest number, but it is not in fact a number. It is a process. It is a concept of not ending. Okay, so we can't say, oh, we include infinity in this. Okay, we just go off forever, not included in infinity. Okay, because infinity is not a number. Right, so that's the domain. One last one. So let's look here. Which of these values have, which of these x's have y? So let's look at -3. Is -3 going to eventually have a y value? Well, this thing looks like it's extending upwards. So yeah, I think so. I think this one does too. And probably if I look at -5, that one does. All of these guys certainly do. And same way for this number 5. So this one actually has all real numbers as its domain. Okay, so kind of looking at what we had before, we go off as far to the left as we'd like. So that would be -infinity. And then we can go off as far to the right as we'd like, positive infinity. Okay, so that one's good to go. All right, this is all real numbers. This is any number that you can think of is part of the domain, because this is in fact a squaring function. This is x squared, what I just talked about. Okay. Oh, whoop, wrong way. Okay. Now let's talk about the range. The range is all of the y's that have x's. Okay, so these are all the things you're allowed to get out of a function. So again, if I go back to my analogy of the Coke machine, the domain is any dollar amount that I put in, but the range is all the possible types of soda and the number of sodas that I can get. Okay. When I talk about algebraically, it says, okay, if I square something, what am I able to get out? Am I able to get whole numbers? Am I able to get fractions? Am I able to get negative numbers? What am I able to get out of them? Now, this question is a lot harder to ask because you have to look at the function itself, not so much what can I plug in, because this one's pretty easy. You can plug in anything you want. But this one going forward is going to be a little bit more difficult. So let's look at this right here. So what is the range of values? What is my lowest term, first of all? That's always how I like to look at it. My lowest term seems to be right here. It's the lowest part of the graph. And the highest point of the graph seems to be right here. So my range, it seems, is 1, 2, 3, 4, 5, 6, 7, 8. 1, 8 inclusive on both of those. Okay? So it's the high and the lows on those things. Okay? Let's look at the next one. We'll run out of time. Might have to post a second video. Okay, again, the lowest value here seems to be -1. And where does this guy end? Well, it might look like it's asymptotic, meaning it's going to slow down and stop eventually, but I happen to know this is the square root function. So this is going to have, it's going to continue to grow very slowly, but up and up and up and up and up. Okay, so this is going to be, again, inclusive, -1, all the way up to positive infinity. All right. I think I can squeeze in one more. Okay, let's look at this real quick. Okay, we start at 0, and then we go up as high as we want. Okay, so this one's going to be 0, infinity. All right, so we'll pause there, and then we'll pick it up with the next video.